Have you ever wondered why a solver bets some flops more often than other flops? I think if you ask any coach worth their salt, they'll tell you that this is just due to range advantage, the idea that one player has more equity and therefore they should bet more often. And while this sounds simple and obvious, the fact is that the data does not back this up. Ideas like range advantage and pushing your equity are largely a myth, and in this video, I'm going to show you why. Today's video is all about determining why the solver prefers to bet some boards more often than other boards. I think if you ask any reasonable coach this, they're going to tell you it's because, well, you got to push your equity. You're betting because you have a range advantage. And then if you ask them, okay, well, what's a range advantage? What does that mean? Well, it just means that we have better hands on average, and therefore we should be putting more money into the pot on average. And that just seems so obviously straightforwardly true that I don't think anybody has bothered to check if it is true. Well, I checked, and spoiler, it's not. Range versus range equity has very little influence on your overall betting frequency. Let's see why. You're playing a 100 big blind cash game. You open the button, the big blind calls. Now, if I told you that your range as the button had 54% equity on a flop, could you tell me how often you should be betting that flop overall? Well, let's put it to the test. The flop comes 4-4-4. As you could see, the optimal strategy is to bet everything, even for a big size sometimes. If we take a look in the top right corner, we can see that you have 54% equity as the button. Now, if you ask any coach why this is happening, they'll say, well, it's because button has a range advantage, they're pushing their equity, they've got better hands on average, and therefore they should bet more often. Okay, sure, fair enough. But let's take a look at another flop. Here is Ace 9-2 monotone, and we can see we have, again, exactly 54% equity. And yet, this time, we're always checking. So what was the difference? Why is it that when we have 54% equity before, we're always betting to push our range advantage, but if we have the same amount of equity on this board, we're always checking? All right? Clearly, there are other factors at play that have a huge effect on your overall betting frequency. My biggest gripe with the GTO community and poker coaching at large is just the lack of scientific rigor. And I don't really blame any one coach. Like, I'm myself very responsible for this. Every coach does this to some degree, is we'll look at some solver output and then just ad hoc some explanation for it, right? Like, oh, it's happening because A, B, and C. What's actually happening here is that people are just kind of like looking at a solver and then just making up explanations as they go without ever really checking their assumptions rigorously, I mean. So the actual best way to build a model is using the scientific method, which involves observation, hypothesis, prediction, experimentation, and evaluation. This is a long and iterative process that involves doing many experiments and slowly refining your hypothesis over time. But we're poker players, not scientists, and ain't nobody got time for all that. However, I will borrow one of their tools for this video. So we're going to borrow just one instrument from the scientist toolkit, and it's called linear regression, which sounds terrifying, but all it means is just fitting a line through some dots. So the question I would like to answer today is, how much does equity explain c-betting percentage? If we get an R-squared value of 1, it means perfect correlation. It means equity perfectly correlates with c-betting frequency. If we get an R-squared value of 0, it means no correlation whatsoever, meaning it doesn't explain c-betting frequency at all. Now I'm testing two different spots, button versus big blind single raise pot, as well as small blind versus cutoff 3-bet pot. And the reason I've chosen these two spots is because I'm trying to cancel out the effects of position as well as different SPRs. So I'm trying to get like a pretty broad view. Okay, let's dive in. The first spot we see is a button versus big blind single raise pot. And here I'm graphing the button c-betting percentage by equity. So on the x-axis, we see the independent variable, that is, how much equity does the button have here overall? On the vertical axis, we see how often they're c-betting, and there is a correlation. Okay, so the correlation is 0.248. So about 25% of our c-betting frequency can be explained by our equity. But it's not that strong, right? Like, we can see that, sure, on boards where we don't have a lot of equity, we don't do a lot of betting. And on boards where we have a lot of equity, we do more betting. But there's a ton of variation in this data. And frankly, equity is just not a very strong explainer of c-betting frequencies. On this next board, I'm looking at a small blind versus cutoff 3-bet pot. Now again, every single one of these dots represents every possible flop. All 1,755 flops are in this chart. And again, we can see a weak correlation between the small blind's equity and their c-betting percentage. The R-squared value is about 0.24, meaning that equity only explains about 24% of the c-betting frequency. So, sure, there is some truth to this, but it's not a great explainer. You can see there are some spots where, despite the fact that we have an overwhelming range advantage of 59%, we're just never betting. And then on other boards where, despite the fact that we're not that strong, we're betting more often. So clearly, range versus range equity is not a great predictor of c-betting frequency. Let me show you an interesting toy game. In this spot, we're in position and we have king-king. Out of position has ace-ace and a whole bunch of trash. The board is 2-2-2-3-3. Okay, so the question is, should we bet in position? Well, let's look at the facts. For one thing, we have 99% equity. Okay, you're in position. This is the last street. You have 99% equity. So by any reasonable definition of range advantage or pushing equity, you should bet this hand. But in this specific toy game, we're up against the polarized range. And if we bet, what's going to happen is they're just going to fold the hands that are behind and call the hand that's ahead. And so there's literally no point to betting when we could just check behind and take our equity. And so clearly, it's not just about having lots of equity. There are things that matter, like the polarization of your equity. For starters, let me show you what actually matters. So the flop is 4-4-4. Let's say we bet 1/3 and get called. Here's the calling range. Notice how it's full of air, right? So we've got just so many trashy weak hands. Even the quote-unquote good hands are only ace high. But let's take a look. Let's say we bet, we get called. We're going to take a turn. Now, rather than selecting some turn card, I'm going to click this button to open the turn reports. And I want you to pay attention to this panel right here. In particular, note that the button has about 58.4% pot share and about 52% equity. What this means is that the button is still ahead after they bet and get called. In fact, they're going to win about 58% of the pot. That is to say, for every dollar the big blind puts in, you're going to win about 58 cents of that on average. And this is a very good indicator that you want to bet aggressively and bet now, because you're going to be claiming a lot of the money that your opponent puts into the pot. Let me show you a different board. This is ace 9 deuce. Again, we bet and get called, but look at what's happened to our equity. It's dropped from 54%, meaning we're ahead, to 42.8%, meaning we're actually pretty far behind now. And let's take a look at the EV over pot, only 46%. So we're actually losing money that we put in on the flop. We're actually behind on a lot of runouts. So we've gone from being okay, we put in money and we're actually earning a premium on every time you call us, to actually we're paying you a premium every time you call. This is not good for us. This is very bad. So the first thing I want you guys to start thinking about when it comes to how often should I bet is, how often is my betting range still ahead? Does my hand retain equity when I start folding out all of the garbage in their range? And moreover, do I even want them to fold out some of those hands? Do those hands even matter against my hand? These are the things that actually drive betting frequency. Let's return to linear regression and see if we can find another metric that better predicts how often some players should c-bet in theory. So we already saw that equity was not a very good predictor. What about expected value? Well, here I've graphed the button's expected value against their c-betting frequency, and we can see there's a much stronger correlation, upwards of 0.46. And in the small blind versus cutoff 3-bet pot, the small blind's correlation is upwards of 0.58. In other words, your expected value for your entire range is a much, much stronger indicator of how frequently you should bet. And this should make sense, right? Equity doesn't account for all the post-flop variables. EV does. But there's a problem, guys. You see, EV is not independent of strategy. Equity is. Okay, if we just plug in 2 ranges into Equilab or Flopzilla or whatever, it doesn't care what your strategy is. Your equity is your equity. It is completely independent of your strategy. EV, on the other hand, depends on your strategy. So do we have higher EV because we're c-betting more, or are we c-betting more because we have higher EV? You see, it's no longer about causation, it is now about correlation. And lastly, I measured each player's equity realization. So EQR is just the ratio of EV to EQ. You can think of it as how well a player can convert a raw equity advantage into an EV advantage. And this happens to be the most predictive metric we have so far. So buttons equity realization correlates much more closely with their overall c-betting frequency per flop, upwards of 0.57 R-squared. And in the small blind, it's even stronger, upwards of 0.71. So, in other words, your equity realization for your entire range is highly predictive of how frequently you should bet. Here it is in the final table. We can see everything all together. So far, we've only been concerned with looking at betting frequency, but another metric we can look at is betting volume. So for example, there are some flops where rather than betting often, you want to bet big. Ace-King 6, for example, is a flop that is fantastic for the button's range, and yet we're checking back half the time. And the reason for this is that the value portion of our range largely prefers this big overbet size. So the natural next question then is, do any of these metrics correlate well to betting volume? Betting volume can be measured by just multiplying the bet sizes and the frequencies. In this case, I'm only measuring the betting volume at the c-bet node rather than in the entire line. And of course, we can divide by the size of the pot to normalize it into a percent, the same way we would with EV. So I'm not going to walk you through each one step by step, but here are the graphs by equity, by EV, and by equity realization. And what we found is largely the same type of correlations. Equity was a very weak predictor of betting volume. EV is stronger. Equity realization is strongest. So again, the size of the bet, like how much money you're putting into the pot, cannot be predicted by these super coarse metrics like how much equity realization your entire range has. The fact is that there are more subtle incentives that drive strategy. However, we see that equity realization correlates more strongly to both how often you're betting and how much money you're putting into the pot compared to EV or equity alone. And it's interesting because EQR is just the ratio of EV to equity. I think it's pertinent to put out a quick warning about correlations. You see, there's a common saying in statistics that correlation does not equal causation. So just because two things are related does not mean that one is causing the other. A famous example of this, if you take a look at this chart on the right, are the number of drownings and ice cream deaths in Spain. And you'll notice that if you graph this by month, they seem highly correlated, right? Does this mean that ice cream is causing people to drown? No, that's stupid. It's just that you go swimming and eat ice cream in the summer more often than the winter. So what's happening here is that even though these two things are correlated, they're both being caused by some third underlying factor, namely the fact that it's summer. The same is happening with equity realization and c-betting. They're both increased by some underlying factors, right? You're not betting more because you have higher EQR. You don't have higher EQR necessarily because you're betting more. They're correlated, but they're both being caused by underlying factors. Now, those underlying factors are hard to quantify, but here's my best take. How well you can convert your raw equity advantage into chips largely reflects how freely you can attack your opponent. I still think that metrics such as your entire range's equity realization, expected value, or equity are far too coarse to fully explain c-betting frequency. However, there are several underlying factors that do incentivize fast playing, and these are things that are kind of harder to measure, that are more nuanced and a little more fine-grained. So first of all, you might think about the retention your hand has after you bet. So after you bet, how much value can you still get out of your opponent on future streets? This is a really important question to ask. We saw on the monotone board that your retention plummets after you bet, whereas on the tripled board, you still have great retention after you bet. Another question is polarization. So we saw in the toy game example that just because you have 99% equity doesn't mean you necessarily want to bet, right? So it's not just about how much equity you have, it's about the distribution of your equity. By the river, are you going to be nuts or nothing, or are you going to have a bluff catcher? That's a really important question to ask. And finally, I like to consider fold equity, not just how often will my opponent fold, but how much value did those folds have against my hands? And you know what? I've actually already made a video about all three of these topics in the past before. So there are various underlying factors that incentivize fast playing. And even these three, this is not a conclusive list, but we're only broadly capturing the trends when we measure something as coarse as, for example, the equity realization of your range. Nonetheless, it's still surprising to me just how strong that correlation is. Now, I realize that what I've done here only really scratches the surface. I think that any data scientist watching this is going to be kind of outraged that I didn't do multiple regression. Like, why am I only looking at one factor at a time when I could look at all of them simultaneously? Listen, guys, I'm not a trained data scientist. I'm not a statistician. My expertise stops at basically fitting a line through some dots, okay? That's about as far as my expertise goes. If you want something further, you need to hire a statistician. I think there's like a lot of work to be done in this area. Like, I've been using range versus range metrics, but you could, in theory, apply the same logic using hand versus range metrics. Like, how much equity does my individual hand have? And how well does that predict that hand's betting frequency? I think that would be pretty useful. I also think you could measure the polarity of your entire betting range via equity buckets. I think that might have some predictive power in terms of like your sizing. There's a lot of work to be done in this area, and I would really like to see some more rigorous methods applied towards predicting GTO strategies. I think that's like a really underserved area of poker theory right now. But nonetheless, I hope you guys liked my very basic attempt at a scientific analysis. I really enjoyed doing it. I really enjoyed making the graphs and doing all this data. Let me know if you guys want to see more content like this in the future, and hopefully it brought you to a new way of thinking about C betting and betting in general. Anyway, that's it for now, guys. Happy grinding.